Hello, AP Calculus kids. It's Mrs. Mickelson here. So crazy, we made it. This is going to be your last lesson on new stuff before we start reviewing for the final exam and the AP exam, which is crazy. So it only took us a month to get these last two lessons done. The last day of school was Friday, March 13th, and now here we are on April 14th. But that's all right. So on Thursday then, since this is our last day of new stuff, on Thursday we'll review. And then on Friday, April 20th, we will have a test on chapter 3. So it'll be on 7-1, 7-2, and 7-3. So I hope you guys had a good Easter break. We will go ahead and start. So today we're going to do volumes again. So whenever you find the volume, you always integrate the area. And this time we're going to do it with the washer method. And why are we going to do it with the washer method? There's two methods on 7-3, disk and washer method. So the reason why we're going to do this as the washer method, first of all, I already set it up for you. As you can see, there's the red line here. That is y equals 4. And then we have the blue line here. That is y equals 4x. And then there's also one more line, which is x is equal to 0. So I will draw that in. Funny, my pen came in. Miss Eckholm told me to buy it. It was a $50 pen because it was a great pen. Yeah, it doesn't work on my computer. So here I am drawing with my fingers again. My husband ordered me a $10 one, which will be in on Friday, but that'll be too late. Anyway, ooh, that was pretty impressive with my finger. So there is x is equal to 0. I would have graphed that with my graphing calculator, but the graphing calculator does not graph vertical lines. So, as far as I know. So there is, I'm going to take that triangle where the red and the blue and the green all meet, and I am going to take that triangle and I am going to revolve it around the x-axis. Now, if you notice, when I revolve it around the x-axis, there's going to be a hole in the middle of it. This part right here is going to be a hole. So that is why we use the washer method. Now, if you don't know what a washer looks like, a washer looks like that. So it looks like a donut. So you can call it the washer method or the donut method. And what we need to do is we're going to end up drawing all those washers, and then we're going to add up the area of all the washers, which is integrating the area. So I am going to flip this line down here the best that I can. So if I move that purple area down here, this blue line would reflect here. And the red line, 1, 2, 3, 4, would come down 1, 2, 3, 4. Here's your red line. And so that would just come down here. All right, so how am I going to figure out? So that triangle chunk on the top would come out towards you on the screen, and then it would go down to where I redrew the triangle, then go to the back of the computer screen and revolve around. So that's going to revolve around. So what's going to end up happening is I am going to end up with I'm going to end up with a donut. So I'm going to have my outside part of the washer, and then I'm going to have my inside part of the washer, and it's supposed to touch the blue and the red line. Sorry, I'm not doing a very good job on that. Well, just pretend. Remember the dots, you just make it bigger. There you go. So there's the outside of the washer and the inside of the washer. And depending on where the washer is, I didn't leave a lot of space to do another washer. Depending on where the washer is, that hole is going to be either really big or really small. But as you can see, the outside of the washer is actually always the same. Okay, so the outside of the washer is always the same. Actually, I'm going to redraw those washers. Hang on. Okay, let's redraw those. I'm going to do it more out here so I have room for two. So there's the outside of the washer. There's the inside of the washer. Now here's another, there's the outside of the washer, and there is the inside of the washer. Oops. So what I need to do is there would be all kinds of different washers. So all of these washers would be piled up from all the way from 0 until way out here, which would be 1. So we'd pile up all those washers from x equals 0 to x equals 1. So if we're going to pile up all those washers, when we integrate, we are going to end up integrating from 0 to 1. And now what we're going to do for every single washer problem is you're going to do the outside radius. So we need to figure out what the outside radius is. And then we're going to, so that would be pi r squared. And we're going to minus it from the inside radius. So our general formula for every single washer problem is going to be pi r squared, that's your outer radius, minus pi r squared, that's your inner radius. And because we're doing online learning, we're only going to revolve around the x-axis. We're not going to revolve around the y-axis. You'll do that in Calc 2. So then this is going to be a dx. So we need to figure out the outside radius and the inside radius. No matter which washer you look at, so whether you look at this washer or this washer, what do you notice the outside radius is? The outside radius is always 1, 2, 3, 4. The outside radius is always 4. Here, 1, 2, 3, 4. So my setup is going to be the integration from 0 to 1 of pi times 4 squared minus, okay, now I need to do my inside radius. Now, if you notice, the inside radius is always the height from here up to that blue line. So watch the arrow, from here up to the blue line, from here up to the blue line. So that blue line is y equals 4x. So this is y equals 4x. Oops, oh geez, that's really bad. Okay. So that's y is equal to 4x. So that means that blue line, that height is y. So because that height is y, this is going to be pi times 4x squared dx. And then what I would do is, because they want it in simplest radical form, then you can, or I'm sorry, that's geometry, I'm doing that next. Because they want it in terms of pi, and you want to be able to use your graphing calculator, I would factor the pi out of the equation. So you're going to go factor the pi out. You're going to go from 0 to 1. 4 squared is 16 minus 4 squared is 16. X squared is x squared. 16 x squared dx. And then I would put this part right here in your graphing calculator. So GC means graphing calculator. And then you can get your answer. So pi times whatever that is, and that's what you can put into the answer. And that will be what the volume is as you revolve this triangle around the x-axis. So you can see there's a bunch of different washers. So on the test, when do you use washer versus disc? You're going to use washer versus disc when you have a hole in your circle. And all of these are going to have holes in your circles today. The ones that we did last Wednesday did not have holes. They were discs. These are washers. All right, next example. We're going to have to hustle through these. All right, so for this one, same thing. I already have this drawn for you to save a little bit of time. So what we're going to do is we are going to flip that down to the bottom, because we're going to take, so we're revolving between the parabola x squared plus 1. Here's your parabola right here. There's your parabola. And the line y equals x plus 3, that's the red one. So sometimes I like make a little mark, so this is blue, and then I make a little mark, this is red. I mean, obviously x squared is the parabola, x is the line, but just in case you forget, and that's it. So that is going to be this space right here, okay? So we're going to revolve that around the x-axis. And in Calc 2, you'll revolve that around sometimes the y-axis or something else, or x equals 7 or y equals 3. But we're not going to do that this year because we're not. So you'll get to that next year. Something to look forward to. All right, so we're going to revolve this around the x-axis. So that little chunk of this little chunk right here, this little chunk I highlighted in green, this thing right here, we're going to revolve down around the x-axis, through the back of the computer, towards you, around the bottom, and then back of the computer, and keep revolving it around. So now this part I'm really bad at. So I am going to copy this down here because it's going to be about the same. So it's going to go through like -1, 2, so -1, -2, and it's going to cut through 3. Okay, so the line is going to look like something about like this. It's not quite exactly, but no. Okay, and then a blue parabola. Go back up here. The blue parabola is going to come in towards and get closer to 1. It's going to look something like this, and it's going to come down here, something like that. All right, so as this revolves around, as you can see, I'm going to go do my washer. I have my outside of the washer, and then when I revolve it around, I get a hole in the middle. And that's supposed to come down and touch the blue line. Sorry about that. Let me redraw that. That was almost really good. All right, so that's going to come down here, and that's going to, so there's one washer. Here's another washer. Here's another washer. So as you can see, I'm going to have all these different washers. So what the integration does is the integration adds up all these washers from here where it meets all the way over to here where it meets. So these 2 points are like super important. This one right here and this one right there, because that is where the washers meet. All right, so what we're going to do is we're going to integrate pi big R squared minus pi little r squared every single time. Because it's the x-axis, this is going to be a dx. Okay. All right, so for every single washer problem, whenever there's a hole, we always use that. All right, so we are going to integrate pi times, what is my outer radius? My outer radius is, I don't know what color to do this in, I need more colors. My outer radius is right here. My outer radius is right here. My outer radius is right here. So the outer radius is always the red curve. That's going to be x plus 3 squared minus pi. Okay, now what is my inner radius? My inner radius is always this right here. Ooh, Vikings, nice. This right here and this right here. So my inner radius is always my blue. So then I'm going to put in here x squared plus 1 squared. And then this whole thing is what I'm integrating. So it's going to be dx. And then again, you can factor the pi out and then put the rest in your calculator and come up with your answer. All right. So if you wanted to, you can stop and pause and look at this. I probably should have wrote this in red, x plus 3, because that is your red equation, but I didn't, now I did. Okay, last one. So the last one is this one right here. Okay, so now for this one, we are actually looking at, this is your blue function, this is your red function, and this, oops, yeah, and then we have x equals 1, so we need to draw x equals 1, so we'll do that in green. So x equals 1 is right here. All right, so this is actually the space that we're going to revolve. Okay, so how do we set that up? So if we were to set that up, we would integrate pi big R squared minus pi little r squared dx, because as you can see, when you revolve that around the x-axis here, you're going to revolve that around the x-axis, there's going to be this hole right here in the middle. So it is going to have to be that. So if you look at your answers, what's the only one that has pi? Letter C. So that's pi. Here's your pi. And then that's your r squared. E to the x squared is going to be e to the 2x minus, here's your other r squared. And they just pulled the pi out. All right, have a great day. Do your assignment. If you have questions,